In this video, we're going to go over section 9.1, which is a basic concept of a differential equations. So let's begin with the definition of what differential equation is. Differential means derivative. So differential equation is an equation involving some kind of unknown function with y, and then we have another function given with its derivative function. So kind of take a look at this one right over here, the very first problem. We have this some kind of an unknown function denoted in y, and we have another function, we are given one of its derivative function. So our goal in 9.1 is just going through basic concept, getting familiar with what differential equation is, and 9.2, and then further down chapter 9 will elaborate it. Another definition to look for is the first order differential equation. That means this is an equation where only the first derivative of unknown function appear in the equation. So you see the just y prime, not double prime or triple prime. So we'll begin with the first order, first derivative differential equation. So let's take a look at the very first problem. In problem 1-2, show the given function is the general solution of the indicated different equation. What does it mean when something is a solution? That means when I plug it in the function into when I'm plug it in the solution into some function, you have same equation out. So that's what we are going to do. We are going to try to plug it in over here into second equation somehow, and then show that this, if I plug it, if I do that substitution, I'm going to end up having this equation. So you have to have the equality at the end. You should have a xy prime equal negative 3y. That's what it means to be solution. If you plug it in and you get left hand side xy prime, and then right hand side not a negative 3y, that means that's not a solution. So in algebra, that's what we did. When we are checking, we plug it in to see if it gives you true statement. So let's do it with the equation. So you're plugging in equation into another equation. So take a look at this. Our solution, our general solution. Now this one is general because C is just general. It's not a number. It's some random constant. So I'm going to look at my general solution and then see that somehow I need to have a y prime up here. So my first thing I'm going to do is I'm going to take a derivative of that function. So if I take derivative, then left hand side it will be just y prime. Now on the right hand side, actually let's do a little bit of rearrangement to make it differentiable friendly function. C over x cube is same thing as c times x to the negative 3, so that we are avoiding a quotient rule. Now let's take the derivative because our equation involves derivative. So if I take the derivative, this will be negative 3 comes down, so negative 3c x, and then lower down by 1, negative 4. Okay, now we need to have our equation doesn't have a c, so we'll do the substitution. So we have equation y equals c over x cube. Now if I multiply x cube and then x cube, I'm going to have x cube y equal to c. So that's I'm going to do that substitution. Wherever I see the c, I'm going to replace it by x cube y. Let's keep going. So y prime is negative 3. Here's substitution. X cube y, x to the negative 4. So this is where that substitution means solution. If this is a solution, then I should have this equation when I plug it in. Let's check and see if I get this one. So little bit of algebra work. I can have x cubed y. This part is a negative function, so x to the fourth. You can see that I can cancel out the x cubed with this one. So y prime is negative 3y over x. Multiply by x over here, I have xy prime equals negative 3y. Indeed, I have same thing at the end. So that means our general function is solution to our indicated differential equation. So that's it. Here's my substitution. Here's my substitution into the equation, and I get left hand side and right hand side equal to each other, so it is a solution. Okay. On MyMathLab, they are going to kind of put it in an essay format, so you have to kind of fill in the blank and then explain each steps. Okay. All right, let's do another similar problem related to the homework. On this one, you can take a look at number 4, 9.117. So same thing. I'm going to be using my equation and then somehow plug it in, and then I should have y prime is equal to negative 4x cubed y. So let's take the derivative here because I need to have a derivative. So this means I'm going to have this part right over here, right? Negative x to the fourth. So that's going to be, you can also think of it as e function, right? So e to the u du, right? So, and then c is a constant. So I'm going to have e to the u, so e to the negative x to the fourth. Now derivative of negative 4x to the fourth is negative 4 x cubed, right? So my final answer is going to be, don't forget the c, negative 4x cubed c e to the negative x to the fourth. Doing the chain rule. Okay, I'm gonna erase this. That was my side work. Now we have a c part, right? You see the term c. I'm going to substitute that with this function here. So I have y equals c e raised to the negative x to the fourth. So divided by e to the negative x to the fourth, divided by e to the negative x to the fourth. I'm going to have a c is equal to y over e to the negative x to the fourth. That's what my c value is right over here. So let's plug it in. Y prime negative 4x cubed. Here's my substitution. Y is equal to e, raise it to the negative x to the fourth, and then e to the negative x to the fourth. E to the negative x to the fourth cancels out. I have y prime equals negative 4x cubed y, which is right over here. So I plug it in C and then it worked. I'm getting y prime equal negative 4x cubed y. So that means our function is the general solution to the differential equation. Okay. Now our last problem is having another condition. So 1 and 2 only had this part given. And then number 3 is giving extra information. We have a point, the x value 0, then the y function is 6. This is what it means, 0 and then 6 input and output. So here we are going to show that given function is a general solution to the indicated differential equation. So the first step is same thing. And then we are going to take one more step and use the second information given to find a particular solution. So that means general solution has the C involved. Particular solution means we can solve for C. So we get a numerical value. Okay, so we'll do the two-step. So let's start with the first one, showing the general solution is our indicated differential equation. So we do the same thing. I will take the derivative. So y prime is equal to, so the 3 is just constant, so it disappears. So 3 plus c e to the x. Okay. Now I have a e that I need to plug it in to check and see I'm getting this one right over here. So this part, y is equal to 3 plus 3x plus c e to the x. Let's solve for c. So I'm going to subtract 3 and then subtract 3x to the both side. I'll put it right over here. So I'm getting y minus 3 minus 3x is equal to c e to the x. Let's solve for c. So I'm getting y minus 3 minus 3x over e to the x. So that is my c value here. So let's plug it in. If it's a solution, that means when I plug it in, I have to get this one right over here. That's what solution means. It works. I'm getting the same result. So y prime 3 plus c is y minus 3 minus 3x over e to the x, e to the x. Cancel out e to the x, so I'm getting y prime is equal to 3 plus y minus 3 minus 3x. 3's cancel out, so I get y prime is equal to y minus 3x. That's good. I'm getting the same result here and here. So that means our general solution is our given function is the general solution for our differential equation. Now the second part tells us that find the particular solution. Particular solution means this is general because c can be arbitrary constant. Now they want you to find the actual c value. So that is a particular solution. So I'm going to be using this one to just plug it in and solve for c. So let's do that. So I have y. So this is step 4, finding a particular solution. So we have this y, we need to solve for c. We cannot just leave it arbitrary c. And then we have y sub 0 equals 6. That means x value is 0, y value is 6. So let's plug it in. So 6 is equal to 3 plus 3 times 0 plus c raised to the e to the 0. So that's 3 plus 0. Anything to the 0 power is 1. C. So I have 6 equal 3 plus c. Subtract 3. So that means c is equal to 3. So our particular solution is c is 3. So our particular solution is y is equal to, so you're basically, you solve for c. That's what the c value is. 3 plus 3x plus 3e to the x. So that will be our particular solution that satisfies the initial condition. Okay, that's it for section 9.1. Very short. Okay, when we move on to section 9.2, 9.3, we'll start adding to this basic concepts.